Hello, my name is Eric Schuler. I'm from the College of Information, Research, and Analysis Lab at the University of North Texas. In this video tutorial, I will walk you through an assessment of multivariate outliers in SPSS using a heuristic data example. In this heuristic data example, I was interested in seeing if there were differences in how much someone loved statistics on a scale of 0, run away, to 100, being head over heels for statistics, between graduate students and faculty members. I also asked participants how much they loved research designs on a scale of 0 to 100 using the same metric. I hypothesized that there would be differences in the degree of how much individuals reported liking statistics and research designs based on these two groups. More specifically, which of these two variables would contribute to group separation. Based on this hypothesis, I would need to run a descriptive discriminant analysis, or DDA. This is the data set that we used in tutorial 1. You're looking at univariate outliers, and now we're going to also include research D, or research design. Clicking over to the variable view, we have participant, which is just participant ID. We have role, 1 being a graduate student, and 2 being a faculty member. We have love statistics, which is just how much the individual loves statistics on a scale of 0 to 100, in research D, which is how much the individual loves research designs on a scale of 0 to 100. Now, we have z-scores left over from our last tutorial, so I'm actually going to go ahead and just delete that because we won't be using those this time around. Now again, I transcribed this data from pen and paper surveys, and here is what the data looks like so far. So we see our participants, the roles, again 1 being graduate student, 2 being faculty, love statistics, in research D. First, I'm going to obtain the descriptive statistics by going to Analyze, clicking on Descriptive Statistics, and then clicking on Explore. Next, I'm going to move love statistics to the dependent list, as well as research D. I'm going to leave the display option for both statistics and plots so I can see the values as well as the box plots here. Next, I'm going to paste this into my syntax. Before I run this, I'm going to add a brief comment as a reminder for myself later on of what exactly I did. Now I'm going to highlight and run this. As we can see, we have a sample size of 16. We have 8 graduate students and 8 faculty members. First, let's look at love statistics. Love statistics had a mean of 90.63, a median of 91, and a standard deviation of 5.97. Now for research designs, there was a mean of 93.75, a median of 94, and a standard deviation of 1.65. Now let's look at the skewness and kurtosis of both of these variables. Now if we look at skewness for love statistics, it was negative 0.376, and kurtosis was negative 0.835. For research designs, skewness was negative 0.253, and kurtosis was negative 0.834. Now, based on these results and the suggestions of Glassnop and Paggio, 1985, the data looks normally distributed. It doesn't appear to be too skewed at all. However, since the data is actually grouped, I'm going to need to look at both of these separately. Note that we've already assessed normality in love statistics in the previous demonstration. So for now, I'm going to focus on looking at univariate outliers on research D here. Now, in order to split the files between the two groups and assess outliers that way, first I'm going to go to Data, select Split File, going to go to Compare Groups, and move Role to Groups Based On. I'm then going to select this and paste it into my syntax file. Now I'm going to open up my syntax file, and I'm going to add a comment as a reminder to myself. So this will create a separation by group. What I'm actually going to do is I'm going to go ahead and take this examine syntax. I'm going to copy it, and I'm going to paste it down here. Add another comment. And since we've already done love statistics in the previous demonstration, I'm going to go ahead and remove it from here now. Now before I continue, I'm going to go ahead and create another syntax below this to turn off this filter. First I add a comment, and then I'm going to type out split file off, and then this will actually turn off that split file when we go to run it. Now I'm going to go ahead and highlight the syntax and going to run it. We'll click on Explore, and we can see now that between our two groups we have how much the research designs, if they're a graduate student, and then if the individual is a faculty member. Now here we can see that the graduate students had a mean of 93.5, a standard deviation of 1.60, and a median of 93.5. If we look at the faculty group, we see that faculty had a mean of 94, a median of 94, and a standard deviation of 1.77. Now let's look at the skewness and kurtosis for students. Note how they're very low. Skewness was 0, and kurtosis was negative 0.31. In the faculty group, we have a skewness of negative 0.615 and a kurtosis of negative 0.388. Now, these are well below the suggestions of Glassnap and Paggio, 1985. But before we continue, let's take a look using the visual approach to see if calculating standardized scores is warranted. So I'm going to scroll down to look at the box plots. As within this box plot, we don't have any outliers below or above the upper or lower whiskers, nor do we see that in the faculty group either. So based on this, I don't think calculating standardized scores is warranted. Since I have only two outcome variables, research D and love statistics, I only have to run one scatter plot to assess the bivariate nature of these two DVs. If there were more, I would have to assess each permutation. Now to do this, I'm going to go click on Graphs, go to Legacy Dialogs, and then click on Scatter/Dot. I'm going to select Simple Scatter, click on Define, then I'm going to move Love Statistics to the Y-axis and Research D to the X. Now you could switch these around, it doesn't really matter. Next I'm going to click on Paste to add this to my syntax. Now I'm going to add in that I assessed bivariate nature of these two variables. So I'm going to highlight and then run this. This is kind of just a visual to see if there's any potential multivariate outliers. Now this relationship looks pretty linear. However, there's this one case in the lower right-hand corner. Now remember, when we assessed both variables for univariate outliers, we didn't find any. However, this means that it's the combination of these two variables that there's one case that doesn't really fit within this nice line. So if we double-click this, we're going to pull up the chart editor. From here, I'm going to go select on Elements, click on Data Label Mode, and I'm actually going to go ahead and target this case in the lower right-hand corner. I'm going to double-click on it, and we know that this is number 7. Now it's important to remember that case 7 was not an outlier univariately on either Love Stats or Research D. As we can see, since it doesn't fall within this linear pattern, that maybe the combination of these two variables, this case would be an outlier on them together. After using a visualization, I'm going to want to follow up and assess if case 7 might actually be a multivariate outlier. The procedure I'm going to run is going to calculate what's called Mahalanobis D for all cases across my outcome variables. Mahalanobis D is a statistic that measures the statistical distance of the set of scores from the centroid. If there is a large Mahalanobis D, the case is more likely than not a multivariate outlier, in which case I should run the DDA with and without the multivariate outlier. The procedure we're going to be using today is called the Multinor procedure that was developed by Thomson in 1990 and was discussed in detail by Henson in 1999. This is a way to assess multivariate normality through Mahalanobis D. It also includes a visualization. This procedure uses a regression to save Mahalanobis D in chi-squared, which is computed for each case, and is then plotted on a scatter plot. If the Mahalanobis D and chi-squared values form a diagonal line, then multivariate normality can be assumed. Additionally, multivariate outliers can be detected through this procedure. If a case is found to have a large distance from the centroid and a high chi-squared, then it is likely to actually be a multivariate outlier. We will continue this tutorial in part 2 of the video series.